Oh, okay. I thought you were like YouTube or.
No, I haven't. It's I'm doing it with a note taker, so I will be from the screen. Do it. And straight to.
This should be more in. And this one this is like when I heard live stream.
Sure, but no.
Camera with
Okay. I welcome it if you.
Well, on that computer, everything on the stack.
Okay, I can log into it and YouTube stream.
Yeah.
No, it's just the.
Yeah, it's like you can have it so that
I started business before I started learning how to talk. When I was 9, my parents up to me, the CEO, but then
So whenever like I was good and can't nobody feel like I could. Yeah. Up yourself in the mirror like
Your CFO wants an up.
this
our family for having come together and built something that we sustain for a long. What we've been here is just all the financial for next for staff.
one of the things this yeah.
Some even I just
Yeah, I mean, I
yes or no?
yeah,
I
just show me one here.
right next just for the
This,
so very central.
yeah, but I you can log in. People links. Yeah. So,
Also not to be first, not to the. Overwhelmed for. I'm yeah.
Yeah, there's a little. I got. I think sort of 5 minutes ago. Too bad. Just stuff.
I have to say, I think something.
I've heard of
if you want to.
Like, you gotta
Yeah. Well,
like I might pay for the bus anyway. So it was only less than a 5-minute walk.
do you realize December because since they've been off, they actually are not getting like this. Whatever. Granted, in the studio. It's true that. I don't. I and they were talking on December, and they're. Then they're gonna. I know. But honestly, I don't know what they're thinking. I didn't. Have you got the job? I know.
My bad. Yeah, interview yesterday. Yeah, I got it. I got it. Well, I don't work. So just for yeah. Oh, no, I can do it. Telling us.
I mean, I am.
It's my age.
There was a great one. Yeah. That's wrong.
He's doing this. AI there's a lot of so and it goes weird indicator. Okay. The user then and then depending on the server, then testing directly. And so, and then he has yeah, the other ones are and your versions yeah. So I did previously. He gave you a series of I do that. No, I just do that. And so I get 50 years expected and really I'm taking a bit. So yeah, that's the thing. Yeah, just want to make sure it gets ready to do. It seems like what's interesting Similar from the.
Well, yeah.
Yeah. Yeah. Except for that. Yeah. It's easy. So you have the notes right there. Yeah. So, I think. Yeah. So they're probably. It's not even before at the time, all of the tools set it up on your own laptop. 10 different laptops. 10 different installs. None of them. A lot better than most. Everybody's
So today we have a speaker who has spent more than 20 years rethinking the architecture of AI. He is the CEO or the founding CEO of Meta-Driven Inc., as well as patent pending Fractal Identity Map. Over the last 15 years, he has spent time building a framework. The slide is really strong. Building the framework around AI systems. And before I pass on the floor to Elias Moosman, I would like to thank Udo for providing the location to us. And please give a warm welcome to Elias Moosman.
Very much appreciated. Thanks, Margaret. Thanks for having me, guys. Oh, we actually got a nice turnout today. I wonder if you know what you're in for. So, I'm going to start with a very simple question. Why are you so people have 5 different perspectives on what a particular word means, and you're basically sitting there making sense out of it. And then, well, if there are 5 people in the meeting, five different careers, you could almost say you're getting 5 hours of mental workout. Think of if you've ever been in this situation. And keep that in mind for the rest of the talk. It's just not coming through to my computer. Well, it's on. All right. How about now? Is this better?
Yes.
Awesome.
I guess you're going to start out again.
All right. So again, it sounds like a very simple question. Think of a time when you've been in a meeting.
1 second, I have to restart the audio.
All right, no worries.
I've been thinking about work meetings.
That is not what this talk is about, but I'm glad.
We're ready to answer your question.
Well, while we're waiting for the audio to work here, maybe. So you have an experience. Share the experience while we're waiting.
Oh. I think it's right. Like, every single company has all these like code names, right? And then apparently some companies actually use code names for their clients. They want to have this security or like privacy guarantees just in case of like when you start a job at this type of workplace, you have to learn an entire new vocab. Regardless of whether you have like technical experience, healthcare experience, built in.
Right. It's true. That's exactly it. A very specific example of this problem. Are we going to be able to get the sharing back, the screen?
Yeah, it's going to come back. Just give it 1 second.
Okay, no worries.
The drivers decided to fail right as we started talking.
Isn't that interesting? We're having all sorts of interesting problems this week. Okay, no worries.
And I'm just sure everyone will work what's going on outside.
But I think the meet is still running, right? Can you guys hear me? Enough not to leave.
Yes, we can hear you.
A bunch. Let me check that there are no more waiting.
Should we just send a message that we're gonna be started in a few minutes?
Sorry about this, guys.
So you're correct. The vocab issue is the issue. We all have different definitions of things, but that's fine. But when we have very strong experiences or different careers, then it makes a difference, a huge difference. It's almost like you're speaking different languages. We'll get back to that.
That's not coming through on the speakers. So I fixed one problem and then another problem. Can you talk?
Does this work? I'll just use my voice. How's that? I think they can hear me, right? Yeah.
Yes, we can hear you.
Can you guys hear me in the meet? We're having issues with the local setup here, but at least you can hear me, right?
Correct.
All right, we got that. Glad to hear it. So we're not going to be able to share screen then in that case, but that'll be fine. So yes, I'll start from the beginning, or actually I'll start from where we left off because we won't be able to record this. So the reason you feel tired after meeting with people with different careers in a meeting is what the book is about in a lot of ways, but it's about the physics of that problem. It's not a philosophy, it's not a metaphor. And hopefully when you leave here today, you'll understand more about how that happens and why it's so important. We track financial debt, we track technical debt, but we don't debt. You could call it ontological debt if you like. And we can actually measure it. So we spend about 20% of our energy on our brains. That's something we can measure. We can actually measure when you have to work harder. And this is not wasteful. That was done on purpose. That is how we got to where we are. I mean, what we think of intelligence, people discuss what that means in many different ways, but we can say that it has something to do with that, right? And we spend about 30 or 40 watts on exactly this kind of work. And we're made for a specific kind of information coming at us. And that is not the kind of information I'll be talking about today. So you can almost say that there's a totally different way of looking at information. I had this, we got that back. We had this up before. I'm going to return to that in a bit later. Okay. When we have that meeting with many different careers in that meeting, we have this intuitive sense that the flexibility that we have in dealing what things mean is a strength. But it's not. If you can't agree on what things mean, then you will spend this extra energy decoding, translating the different meanings, the different drifts between what we mean. And this is not just on a word level, it's much more involved than that. It's actually better to think of this as grounding, as having physical ground under your feet, to be anchored in reality. That's a much better way to think of it. What we experience with our senses is 100% certain. That's much more profound than it sounds. Everything else that we deal with in the information systems that we use are a story about a story about a story. It's basically ungrounded. And you cannot have any kind of freedom or agency when you're ungrounded. Flexibility in what we mean traps you. It robs you of your freedom, of your agency. You can think of it like walking up a ladder. If the ladder conformed to your foot, you'd fall down. And in the book, and the way to describe the technology is a way to fix this issue. No small issue, but that is what it is. It's about the symbol grounding problem. If we cannot agree on what things mean, what takes its place? Nature abhors a vacuum. And what takes its place is pure power, basically. It means that symbols lose their grounding. We are ungrounded. And you need a stable foundation in order to make any kind of comparison. So what happens when we become ungrounded in how we understand the meaning of things is that we get drift. And we can deal with this to a point. In daily life, we have grounding. We have grounding in our experiences, and our experiences are 100% certain. So every step you take away from your experience, you're drifting. You've come up against this problem. We can actually calculate that with what I'm about to talk about. We can calculate it. We cannot do this with words. There are no variables in reality for your C code or JavaScript. There's no translation between text and reality. It relies entirely on this kind of thing. Or it's a story about a story about a story. And hopefully, I'll make it clear how that is a no-go for a lot of the really bad problems that we are facing right now that have to do with the big questions, the questions about how to achieve autonomy, how to deal with change, how to communicate effectively, and how to avoid those meetings that are the 5-hour mental workouts. When these meetings float, there's no other alternative. The alternative is power, basically. So imagine that you're dealing with a normalized situation, like you have several different entities, call them maybe school systems or legislative areas that have different definition for things, like different definition of a calendar year for schools, for example. And if you don't resolve those things, this is actually something Margaret, our host, knows something about. This creates a real issue. You cannot organize without resolving these things. What I'm trying to make clear is that this is not a intellectual problem. This is about energy. This is physics, basically. I'll hopefully make that case clear by the end of the day. So this has been 25 years of work for me, basically. Not all the time, but yeah, I've been working on this for 25 years. And hopefully I can get to the point where, with what I'm saying here, that we get to the understanding that what we need is like the difference between calculating with water or standing on ice. It's a phase change that I'm talking about. And I believe that I've solved that. And that's a big claim. I look forward to your questions. But that's what the level that we're dealing with here. Since the 70s, basically, there were 3 papers. The preface of the book talks about this. One of them was how we deal with databases and information technologies, and the third normal form. And what that does is that it scatters meaning across many different positions, and that leads to this kind of issue that we're always translating. And we can do it as long as we stay in a very specific area, right? But that is not how reality works. And if we want to be able to understand the difference between what we said and what we got in the real world without relying on observation, which we can't do when we're moving very fast. It's like driving a car on an icy road, for example. It's not a bad analogy. We don't have a steering wheel without something like this. Because you always end up in a situation where you rely on human translation or debate and discussion, which just doesn't work in the kind of scenario we're in. So it might work now, it might work yesterday, but we're going too fast for that, basically. We need a new kind of constraint. And as I said, that flexibility doesn't give you freedom. It actually robs you of your agency in this case. So the constraint is not a constraint of you. Very counterintuitively, when you constrain the meaning of symbols, which is anything you attach to an experience, basically, you become free because you have solid ground. And that's what, yeah, I think I can show that now. I'm going to return to this many times. This is actually a picture of what it looks like. This is a 12 by 12 grid with 3 different symbols or 3 colors. And it's right at the limit of what we can make sense out of with the same machinery that we use to understand faces. So it's about 17 bits of information in one change of 2 of these. We can understand about 175,000 faces, so give or take, that's about 17 bits of information. If you put 4 of these next to each other, you achieve precision that's more than what you would need to pick 1 second out of the age of the universe. So that's measuring drift beyond words, and it's doing it with the same machinery that we use to understand the world. And I don't know how to say this properly, but that turns on the light. Now, you have a way to navigate. It's called the Fractal Identity Map, and the reason it's called that is because identity is what a symbol is, and you can have as many stories about what that means as you like. But actually, every time you do that, every time you make a story about a story, you drift from where you thought you were, basically. So another easy way to, I hope, try to get this across is, say that you ask an AI to write you an essay, which I'm sure nobody has ever done. And say that this essay is written about a subject that is beyond your expertise. You're not in a great position to evaluate whether this is the same essay that you wanted to write, or it lives up to the qualities that you can talk about it forever, right? To be able to understand that, to map that out, you need something beyond words, basically. And that is what this is. This has several applications. One of them was for the app that you just saw me using, which is for sales. And another one is for permissions. So permissions and identities are very similar. They have to match, right? So if you have the definition of an identity and you have the definition of a resource, either they overlap or they don't. And for people, we can do this with lists. Speaking of lists, if anything has made sense so far or not, there's only one thing that I need you to take away or believe based on what I'm talking about now. And that is that sorted lists are easier to deal with than random lists. And this isn't a sorted list. This is more like a sorted list for reality. It's a sorted list for a problem in a way that you can never do with words or anything like that. It's a semantic map. So each one of those positions, the position is actually its meaning. So this is unique, and that's what the book is about. And because each position has a meaning, and the position is its meaning, that's the unity principle right there. The unity principle, S equivalent to P equivalent to H, it means that the semantic is equivalent to the physics, which is equivalent to the hardware. And if you draw one of these for a problem or an identity, and then the reality drifts away from it, you don't get words back. You get areas of drift. You get areas of difference. And those can be interpreted with the same machinery as you understand faces with in one shot like this. Which completely changes the problem of understanding what this is.
Do you want me to pass the physical pieces as you have these numbers?
Yes. Let's do that. So first I'm going to hold it up to the camera, show what's going on. So this is what it looks like physically. This is a kind of a fractal shape. It's a very simple version of, it's the same thing on the screen. But because this is a row of pyramids, this is a row of rounds, and this is a row of smooth, same in the other direction. And the same thing happens here. So you got pyramid, rounds, smooth, and then you have the blocks of the same area, pyramid, round, smooth. And what that does is that's a two-dimensional version of this kind of, I call it tesseract physics. You can take that as you like. It can go in as many dimensions as you want. But what it does is that it crosses over into the same way that we deal with faces, basically. It's a semantic map. It's not a physical map. There's no numbers. It's based on the position. The semantic is the position, which is physics, which is hardware. So if a problem drifts from what you thought it was going to be, it actually makes a computer work harder. And that gives us hope that even in extremely fast or complicated situations, we can resolve the issue of the 5-hour workout, brain workout for the meeting with 1 hour, right? It means that we can actually get to a point where we have the same meaning for what we are saying. We can actually verify the difference between what was said and what has actually happened. I'm going to pass these out. You can feel them and look at them. You can ask any questions.
Some of them you have points. They are different. They are not all.
That's the trick to them. So I think I can hear the meat as well, right?
Perhaps.
Excellent. So I was hoping to show some more things related to this and also take questions and dive deeper in this. And I want to know if I made any sense at all, because this is, it is somewhat like I'm pointing out there's a new color. And if I haven't done my job right, you won't be able to see the color. And that's on me, not on you. I'm just a guy who figured out how to turn on the light, basically. It took me a long time, but that doesn't mean I figured out how to explain what's going on here in a clear enough way. All right.
The whole thing, of course, is pattern. There are two general football patterns. And I'm interested to know what the relationship of those patterns are. The holes represent a pattern that's at a 45-degree angle to the rest of the patterning.
Yes, the holes are, you can think of them as surface tension. It's different from this. The holes in that one, they're potential. They would want to take on the shape of one of the nearby squares, basically. That's what they are. So if you're dividing a 3x3 into two groups, it wouldn't divide cleanly like over here on the screen. The top one over here, these are green and these are red, right? But that's not a half-half. And if you're dealing with two gradients in two directions, which I'll give you guys keychains at the end of the event, then you would see that the key to what I'm showing you is that the positions are binary. They're not relative. A position is a coordinate, but it's a coordinate in a semantic space, not in a number space. So on the physical ones, the ones that are split, which you can't have a split one in a binary case like that, you have to pick a symbol, and the symbol has to be in a location. But because of how up and down, for example, corresponds to how strongly it is associated with the category, that would affect its meaning, right? But the holes are basically potentials, and they just work out that way. In the areas where you get a split gestalt, submatrix, they would look like that. And I hope I answered your question. All right, appreciate it. So, go on, please.
Is this something that you perform yourself with people? Are you able to use this yourself when you're listening to people, like in meetings and so on?
Hard to say. In the book, I say I do.
Okay.
I can make a strong case for it, but that is not the case that I'm making. There are consequences of thinking of things in this way, but it's hard to say. It's not like a mnemonic in your mind. It's more of an appreciation for. Let's do an example here, right? This example on the screen shows a journey. It shows a journey, and I'm using the simplest possible symbols here. So this right here is a one-dimensional axis, but it's organized in a very particular way. To your point, if you think of in this way, what you would do is, in a problem situation, you would estimate what are the most independent, statistically independent categories that are important to this problem being resolved. And you can do that, and LLM can do that just fine. You can iterate on that until we understand what's important here. You can think of them as KPIs or whatever you like. And each of those KPIs would have things that feed into them causally, right? So these first three, you could think of them as the top categories. And if I'm using it mentally, then I would treat this first area here, these three, as they're themed after the first one. So these are happy emojis. This is the mind-blowing emoji, and these are the idea or invention emojis. And these are this is the devilry emoji, and this is some sort of.
I want to make sure that when they talk into the mics, that everyone can hear them. For the
So
when you do this, what is it like for you? What do you experience? Is it something that you're thinking of, or is it something that you feel?
I'm not. So this is code, right? It's supposed to be used to understand, for example, permissions, the difference between what you asked for and what you got. So I'm using this explanation is a metaphor. I can't exactly describe how I'm thinking. I can try to answer, because I've been thinking about it for so long, that yes, right? If you really map out all the intersections in this way, you would cover the whole problem. You would think of all the interactions causally. If you use statistically independent categories, or orthogonal, whatever you want to call them, then you would be pretty comfortable that you've covered the whole problem. So analysts love using grid systems, and that's not this, right? This is a whole different type of thing.
So would it be something that you feel, or is it just something that comes to you, like from out of the blue, you get a sudden answer, or is it something that you you feel coming up in your body, or is there a sound that you hear? How would you experience that?
Actually, you're holding it in your hand. So this is the key. If you look at what you got there, they're organized into gestalts. So each 3x3 is organized into a unit. The same way you can recognize a face, because a face has about 17 bits of differentiated information, you can look at that thing and notice what's different. You notice, you just like what's on the screen now, that story, it starts out on here in the devilry area, then it goes up in here, which is an idea, happy ideas, and then converges on the happy area. That's with almost no that's very little differentiation there, right? But you can track that trajectory with precision that is much higher than you can with numbers. I don't think any human can come even close to the amount of information that gets across.
And you experience this, so you'll have something like this in your mind. Is that actually? I'm just trying to understand what it's like.
I'm not making that claim. It's a different claim. Maybe I use a heuristic that does something similar, which basically means that I'm not making decisions with too much information or too little information. I don't think that way. I just want to make sure, have I thought of the important things here, and have I sketched out the map of how they interact in this sort of way. So each of these gestalts are interactions. So the happy to the ideas are these guys. That's over here, for example. So if something happens there, that's no more difficult than reading a face. There's a happiness to idea causality happening here.
Yeah.
I mean, I've had this question before. I struggle because you're asking me to describe how I think.
Yeah.
Maybe not. I don't know.
Getting sense of it. Yeah. I'm getting a sense of how that. It's a different way of experiencing things, isn't it?
Yes. It among other things, it teaches you how much information you can crunch in your head without getting overwhelmed. So if you create this grid, and if you understand what's important in a situation, and you are grounded in that, then you have absolute certainty that you've done what you can do. I mean, it might not be perfect. Maybe you chose the wrong things to focus on, but you did the best you could with the decisions you did. And so one step leads to the next step. And this makes it graspable. 4 of these, which is what you're seeing here, gets you precision of the age of the universe in seconds times 100. And that's 4 faces next to each other, basically. That's a lot. That's a lot of precision. I think we can. That's a lot of discernment. I appreciate the question. Appreciate it. Thanks.
We have another question.
Oh, nice.
You got to turn the mic on. Oh, it's off.
Hello? There.
I don't.
Good evening. Seems like we're talking around the elephant in the room, which is if you show an example of how to encode one of these maps or how to decode one of these maps.
Turn the mic off when you're not talking. Got it?
Okay. So, yes, I have code for that. It is code, right? To do this properly is more involved than one person can do. It's I can explain the code. How's that? The code, the steps are basically this. Sorted lists are easier to deal with than random ones. Therefore, you'll have more cache misses if you're dealing with an unsorted list of the problem space or reality based on that semantic map. So the first thing you do is you try to understand this area and you pick the most independent and most meaningful characteristics of this area. That's the first, that's the 3x3 in the corner there. So that's the pyramid, the round, and the smooth. This is a very simple one. It only has 3 colors, basically. You could do much. 3 is not a lot. And then for each one of those 3, in the same order that you put those 3, you do their subcategories. And because this is the only way, and this is what the patent is doing, that's the only way to do it that I have figured out. So that what you're holding is actually extremely unique. There's no other way to do it, basically. This effect where position turns into meaning or meaning turns into position is unique to that. So the axes are symmetrical, which means that however many dimensions you deal with, you can decode it with the same kind of information. If it was just a nested hierarchy, for example, it would not be meaningful in the same way. That would break this effect. So this step involves using human or LLMs to populate those axes, then either getting experts to fill in how relevant one thing is to another, or letting the LLM do it, and you'll get the quality thereafter, right? But the key is that you do that, and then you have an observation of how it changed, or how a group of people understand the area. And because those changes are visible in this way, that we can make sense of it the same way as you make sense of a face, that leads to this effect. So that's in round terms what it does. Is that a satisfying answer, or you wanted to see a demo? I'm working on this project over here, which I can show. It's an open source project to do this for code bases. And it needs a lot of work. Maybe you'd like to help me out with it. It's called Intent Guard. What it does is that it takes your code, and then it takes your documentation, which is your intent, basically. And it runs a lot of different kind of calculations. There's a lot of work to be done on it. And the way it works out with what you're holding in your hand is the top right corner is the documentation, and the bottom right is the alignment with the code. And that way, if there's a hole in your documentation, but not a hole in your code, in that area, the corresponding area, that means you're not documenting code that you have, and vice versa. So your alignment between those two, if your code says what your documentation says it's supposed to do, gives you a grade, and that's what this is. And it's an open source project, and that's a rudimentary version of that map. So you can see there are cold spots and there's a hot spot. So this is a lot of documentation, and there's a little bit of code, and most of it is organized around here. So that's the place you wouldn't focus on building, you'd focus on the other places. But in a mature project, it would look different. So that's an example of, that's a demo, if you will. You'd run that on your computer, on your code. This would be generated. You would work with it until it sets up the right categories, and then you would track those categories over time. And you can draw frames of this, for example, to see the progression. And the key here that's a semantic map. That's not a map of numbers. That's actually a map of ideas. Those are the map of the ideas that matter in this situation. So if one of them starts drifting, then you can see that. You can also see where to focus your energy, because there's a hole in that area.
And then is the fact that it's almost diagonally symmetric in the case of a couple of examples that I've seen, and this one is perfectly diagonally symmetric.
That's the canonical case.
Okay.
Yeah.
So this is like the most aligned, or most aligned, or
You're asking a much more profound question than you think, so I'll try to answer it. The canonical case is this one has been populated, right? So you can almost think of the one on the screen as changes to that one. So it starts out like that one. That's the zero case, because it's describing what the areas mean. So that's why, so that one actually is position as meaning in the zero case. And this is changes to the one you're holding. Yeah. So there's a lot of information in the one on the screen, much more than you could write out in numbers, probably. if there was only two things on the screen here, two numbers, that would be two changes to the thing that you're holding. Yep.
How does this relate to AI?
That is the trillion-dollar question. And that is why this basically. AI, I'm thinking of how to answer this question. The simplest way to put it that I can think of is to understand the difference between what you asked for and what you got. So in physical space, if a self-driving car drives into a wall, we can see that. Everyone knows it drove into the wall. There's no ambiguity about that. But when it comes to information, the difference between what you asked for and what you got is a much, much harder thing to define. And unless you can understand the difference between what you said and what you did, you will never be able to steer. You're driving your car on an icy road, basically. So this is what you would need to steer. And it's a completely new branch of whatever you want to call it. And without it, basically, you'll find a lot of people talking about how this is impossible, because it technically is. We don't, but other than this, there's no way that I know that you can, like, words will not do it, right? It's a story about a story about a story. This is how you would measure drift. And without this, you can't self-align to anything. So the book goes into a lot of depth about what the consequences of this is also for AI. And it goes into how I came into doing this. And it's longer than I can do in 20 minutes. It relates to AI as a steering wheel, basically. It's understanding the difference between the inside of what you intended and the outside of what's going on.
That would be useful for AI to manipulate.
Absolutely, absolutely. And if you keep it in this way, then it's within the realm of us being able to decode the differences. So it's both self-aligned and it's interpretably aligned with the semantic space.
That would be one step on the way to AG.
Maybe. That's not the case that I'm making, but it makes sense. It's an easy leap. It's an easy leap to make. It generalizes something, right? I don't know exactly what it will lead to. What it does is that it deals with verifiability. I think that's the one word that blockchain and this has in common. If you can't verify the difference between what you said and what you did, outside of words or numbers, because that just won't do it. We don't have the language for that, basically. Then you will never be able to have verifiability. There will always be edge cases or small nuance changes, or it will go so fast that you'll drift a little bit every decision you make. And if you make decisions really quickly, doesn't matter if you're 99.99% accurate, you'll be somewhere completely different very quickly. There's no way to bring yourself back, because that's what happens when the symbols drift, when their meanings drift. The faster you go, the faster you crash, basically. There's no other way to not. We know how to not crash because we are grounded in physical reality, basically. To get this point across properly, I have to have made the point that semantics and how we deal with physical things like self-driving cars, that's not the problem that I'm talking about. It's not drift of the car, it's drift of what we meant. It's the same kind of drift it takes to run an organization. You set a goal, and then for some reason we forgot what to do. That's a simple version of it. We're doing something different than we decided. So we have ways of dealing with it in human systems, but it's when you go fast, you drift faster. You don't have any way to re-anchor yourself to reality, basically. Yep.
So, kind of from a simpler understanding, say you're talking about using these theories and these symbols to help bring back someone who is constantly working to understand how to remember, use AI in these systems to basically create a way to remember faster, sell faster, what you're doing, whatever it may work in individuals' businesses. It's a way of thinking faster, of some sort that you're kind of talking about, right? A way of kind of using these methods not only with AI, but also in work environments or like from what I've read in your site, the CRM or training CEOs to be better sales guys is what you're saying. So if I have like basically lists of things to do, there's so much on my plate, you're saying, hey, I've developed some theories, some methods to kind of wrap around, show you these theories so that you can eventually kind of work faster, work smarter, things like it, of that theory. That kind of where this is. You're trying to explain that that's kind of the end goal of results of what your theories are. It's in the end thing is how are you going to get through that list? How are you going to not be so tired after the 5-hour meeting? All these things come with, reprogramming of some sorts of your brain in a way, or methods that you're teaching in your book. Is that kind of where you're going at here?
I'm not actually sure that's the end goal, but it's definitely a step. It's a necessary step. The what you're talking about is what's on the screen now. It to learn faster, you need to know where you were or where you are. So these are checklists basically, but the way that you might be able to put them together to learn from transcripts, to get an overview and map of your activity, that would, because you can take all your stuff and you can give it to an LLM and you can ask it, so what can I improve? And it will answer. It will write a whole essay about how it can improve. But that is ungrounded information. That's a story about a story about a story. It's better, it will let you learn faster, but what it doesn't do is to give you verifiability. If you can verify those learnings, those lessons, the data that goes in and the advice that comes out, then it's not just that you'll trust it more, but you'll be grounded. You'll be able to, you'll have freedom, because the problem is constrained. So you can have solid grounding, you can be free, you can have agency, and you can learn faster. You get an overview, you can track the things that you care about, whether they're KPIs or something that's much harder to understand. And you can understand how those variables all move together. And that's a much harder problem than current tools can deal with. So we're going to do that with straight up different types of LLM solutions, but we will not have the map without this. We won't have verifiability without this. It's basically going to be giving you advice that you cannot verify. And you can trust it, and you'll probably be fine, but it is a story about a story about a story, and you'll never get there. Which will maybe your brain won't hurt so much, but it does create this drift into different silos, and it does create lots of versions of what I was talking about. But with a map, you're grounded. With a map, you decide what you care about, you track what you care about, and you learn faster. You know what's what, basically. That also, once you're using agentic systems in your business, like what you do with the receptionist, the AI receptionist, right? You will be responsible for a system that is the best that it can be now, but it is ungrounded. If it messes up somehow, you can say we'll do better next time, but you can't say you can do better next time, because once you plug one hole, that's just one hole. There's one statement of we messed up with this. All right, maybe it will not mess up with that next time, but it leaves an unlimited space for other things that can mess up. So you can't say we'll do better next time, really, because the system is still full of holes. And that's good enough for now because we're not moving so fast, but it is a huge problem when we move faster. So I'm not building this. What are you, the sales tool I'm building for right now. But the book is about what we will need when we go faster, when we have more capability. I hope I answered your question. All right, I appreciate it.
So in the more capability, where to layman's terms, what do you mean by that? More capability.
I mean,
How do we need to ground and how move when things get faster?
The map you saw is both how we verify it, because the reasoning trace through that map is the verification. That's what happens when meeting is positioned. So that's one. And how the capability, there's many ways to talk about it. It's a very complicated thing, but one thing could be just faster, right? And if it makes more thinking steps, then the amount of drift that it incurs between those steps will be also more. It's a story by the story by the story by the story. Even if it looks super coherent and exactly what you wanted, you really don't know if it looked at the right information that you wanted to look at. Does it care about what I care about? Does it, did it not take into account something you don't want it to take into account? These questions are unanswerable, basically. We can guess what variables were important in making a particular decision, but that's not the same thing. It's still a story by a story by a story, which is fine for people because we don't move at light speed. And that's the basic argument. Because when you move at light speed, you'll drift, and you'll drift in ways that, so if I tell you that we fixed 95% of all hallucination, and people say, great. And I say, which 95% did you fix? The ones that I would have fixed? Because if it's the ones that I would have caught, then you just made my life more difficult. It means it's drifting in all the ways that I can't catch. And that makes it just better at fooling me at doing what I asked it to. So there's, maybe if I was an expert in a field, I'd be able to craft it to be exactly what I needed to be in my field, because I'm at about the same level as it is. But if it's doing something in information that is beyond what I can do, I don't really have a way to verify it. It's running circles around me. I would never know. Maybe I'll have consequences from it. Maybe I won't. But I can't with a straight face say that if it messes up, I'll be able to fix it next time. So it's a liability thing as well. It's an insurance thing.
So we have a
Oh,
question back here.
Okay. So just let me try to see how much I'm actually following here. Okay, so the problem is that when we use the same words, even between people, we mean different things, and the machine is definitely going to be meaning different things. And there are a lot of information and then which is like why you're using this particular tool to encode that information. Is that correct? But then like we still follow the problem of like how do we encode that information into this tesseract mapping? And that's where I'm not following the verifiability, because then it's gonna be the same problems, unless you're saying that like it's still better than what we had before.
You're not all wrong. It's incomplete. You got the basic point. It's better to use a specific example, right? This walk here, if you could call it a walk on the screen, is steps of changes in a problem space. When you walk across the map, or if there's friction in any part of the map, that tells me that your definition isn't matching reality in that area. If you're asking about, like, for example, if this is a medical diagnosis, which is high stakes. People will and are using AI, and it's doing better than people. And you'd be fool not to believe it, right? So but you're still looking at an image or whatever it is, and it's telling you one thing, and you can even point to where on the screen something has changed, and you can pull out features and all kinds of things about that. But let's say, for example, that you have a list of conditions or things that you really care about, or there are things that you don't know are important that might be important. You don't. It's not easy, let's say, to know that you've covered all the eventualities with that map, or that you took the right things into account, or that you discounted the right things. You still get an output from a black box. So it's verifiability means that you can make a map out of what symbols to take into account, and if and when you go into those buckets and use those buckets, you can reason about, can we verify this path? Did you actually take into account the things that I wanted to take into account? And that sort of answers your question, but it might need a longer one. Did you ask a more general question than that, or was that kind of the question that you asked? Or did you ask how to encode information in this? Yeah.
I guess like a sub question is like, how do you agree on the encoding system mechanism, right? Like between you and other LLMs, for example.
If you and a business partner were to try to encode your goals, like it seems like they can be, would they start to converge, or like will you get us, like I can imagine that there can be slight differences between the two, but would it be similar, or do you see the similarity?
This is a much better question than you might think. Decentralization means that you can have completely different ones, but you can reason about how they're different. You can actually compare them with different things. And if you identify pivot points between them, you can add both of your maps to the same one of these things. And because of that, you can connect the dots between them. So you basically fill in the areas. You can imagine that if you take two of these and put them next to each other, not exactly like that, but basically like that. The fractal scales forever. So if we do that, we can reason about how is my definition of this different from yours in these areas. Now we have a map of that, for example. That's the advanced case. But the easy case is we just agree on what's important here, basically. So we discuss can we agree on these most statistically independent categories for this area? Great, we agree. And this is the order that we believe they're important? Great. All right, and then you can pick the subcategories and you do this. And you have a shared map. And you can attach as much meaning to that map as you like. So if you want to go really down the rabbit hole, each one of those squares might be a whole map. That's definitely possible.
I guess we have questions in the chat.
Oh, cool.
Just so we can sit for the last minute.
Oh, wow, we have a lot of questions. Appreciate it. Benito asks, where do you start? What is the initial knowledge base? List of grounded symbols, definitions. How do you feed enter new data? How do you query the FIM? So practically, that is probably a lot of the heavy lifting for that is done by LLMs, but it's also sort of an iterative process with people involved in it. I would say that's the most practical way to think about it. The grounding doesn't come from the fact that the map is correct. It comes from the fact that a position of one of those items is absolute. So you're grounded in this reality. It's not grounded in the reality, because that we do that because we are physical beings, and the thing that I missed in the talk is that neurons that wire together fire together. That's why the book is called Wire Together, Ground Together. So when we do neural stuff, we have exposure to physics. That's physics, right? We are physical beings. Our calculations are based in physics. The calculations that computers do strip physics as far away from it as possible. We literally separate physics from what we do. If physics gets involved with what the computer is doing, I mean that, it's supposed to be handling symbols, not physics. It's not the same kind of thing. But when we do it, it literally is. We are in contact with reality. If a computer is in contact with reality, we call that, I don't know what we call that. That doesn't happen, basically. This is the separation principle, the third normal form as well. We don't just stop at symbols, having exposure to physics. Logic is separated from physical location and storage. And that normalizes and scatters all your information. So everything you do is recombining that, which means that in a vector database, for example, every location is arbitrary. But the numbers don't mean anything. You figure out what the numbers mean by looking around you and figuring out what's near you. That gives, but that doesn't make the position itself meaningful. Because what this does, what you've seen now, is actually meaningful position. It means that every location has an exact meaning. That's the consequence of this. And I'm not sure I made that point clearly enough. So Benito, I appreciate the question. You used the word grounded. So it's grounded in this structure. It's how you fill the structure is not my department, in a sense. It's the negotiation you have with your business partner to get the priorities right. It's it may be the dictionary. It might be one of LLM outputs, but it defines problem spaces. It's not at one central map. You can have as many maps as you like, effectively. Travis asks, is the printed grid similar to a high-dimensional embedding as used in vector databases? Apparently, I might have answered this partially, Travis. It's fundamentally different because position is meaningful. Vector databases can only deal with proximity. They don't deal with, as far as I understand, I missed something, someone will tell me. Proximity is not position. They're fundamentally different ideas. They're not even close. How are the algorithms defined to drive the model? Does it matter what the rules are as long as they are applied to all inputs the same? This is the same kind of questions as before. It's an input question, it's a content question. And how we populate these things, that's what humans would do, that's what an AI would do. I tried to describe the simplest version of the algorithm. They are not, I would love for this to be applicable straight into a transformer or to a neural net. I can't promise that's the case. Maybe, who knows? Maybe you can grow one on the structure. That would be cool. I haven't tried. Sounds expensive. Transformers, they care about proximity and position in different ways than this. It's a very different idea. This is more like the sorted list for meaning. The sorted list versus random lists. So random lists are more difficult to deal with. So that's the level we're talking about here. Benito asks, okay, Travis. I don't understand when you say you can never describe this in language. Okay. So another talk I started by saying, well, one way to answer that question is the map thing. If you put 4 of these next to each other, we can use the same machinery we use to decode faces to the precision of 100 times the age of the universe. That's a lot of words. We can't deal with that many words. Not even computers deal with that many words easily, right? So in that sense, the precision, this precision is the word. Precision is what this does for you. It creates precision. It creates so much precision that you can probably, and this is what the book says, my hypothesis is that we humans achieve such high precision because we're throwing so many dice that we get collisions between what's going on inside of our brains and what's going on in reality. So it's basically, if I'm right, we get precisions that's higher than what the universe allows for, basically. And that's how we get consciousness. Because if you roll a die, if you're trying to paint the same section of the map with 2 different pencils, the universe goes, no, you can't do that, basically. That creates a problem with causality. And that would create a collision which is 100% certain. So my theory then is that consciousness is these 100% certain events. So that's not exactly how it's different from language, but it's a threshold event. It's precision of these collisions that exceed what the universe allows. And it goes like, no, you can't do that. 1 + 1 is not 99. And then it goes, well, let's figure out what you actually meant. And that creates a collision between what's inside of us and how it would have to be in the outside world if that was true. And that creates an inordinate advantage. It's not just about speed. If I'm grounded in reality and I'm not drifting from reality, right? I'm not hallucinating. And by hallucinating, I mean I'm not losing grip on what actually is going on here. And I'm competing against something that is just reactive, just responding, and does not have the same kind of grip on reality. Doesn't matter if it's moving faster. If it's moving faster and drifting more, it will crash before I do. So I actually win in a competitive race in that situation. It might sound like wishful thinking, but the theory bears this out. It basically means that I can adapt faster because I'm grounded. And being grounded in something is an advantage. That would explain why we have large brains. And that we are not purely reactive in that. Uncertainty versus precision from the Benito. Can you account for it? I cannot account for it in the simple case because to me, in the semantic space, they're about the same thing. I'd say they're basically equivalent. If you have a 100% certainty, you also have 100% precision in a time and space scenario. So I'm conflating them a little bit here. If you have absolute certainty, you also, in a sense, in this view, you have 100% precision, which shouldn't be possible. We don't have any other place where that could happen. But this would do that. If you had a large enough one of these, or if you had enough of them next to each other and they match somehow, that would mean that you got that precision. Those numbers are easy to run. This is what the patent is about, basically. If you look at this, the reason the key to this set of 4 has 17 bits of information per thing. That's about as much as a facial expression, right? But the actual content of the map is different. So the key is as much as a face, but the content of the map is basically unlimited. And I say that full well knowing that it sounds impossible. It's unlimited because if a position has a meaning, if one of these, like if it is where it's at, then when this row, this column of values here propagate that quality of meaning position. And that means that it propagates again and again, basically unlimited. So as long as it's not too empty, it basically propagates unlimited iterations. You can write that out by saying, by making arrays basically of those. And that has to do with how you would do verifiability here. But it is basically unlimited. So the key is 17 bits, but the content can be basically unlimited, even on a 12 by 12. Ridiculously high, which I'm not certain exists anywhere else in any kind of stuff. So that's how you get to this threshold event that I'm talking about. I need to ask, is it possible to account for time, discrete step sequence, different, continuous? Yeah, they're discrete steps, basically. That's the whole point here. Because this map can be binary, but it's achieved this precision effect. The time would be sequential, discrete steps. And if you really want to go there, I guess you can't have more of those than Planck, if you care about that. Deterministic precision. Yeah, that's the whole point of if you have deterministic location, you have the deterministic precision. That's the whole point of meaning is position. Position is meaning. It has an absolute position. So it has an absolute position, but it's also relative in where inside of a gestalt or where the gestalt is on the map. So if it's higher up, you can read it as having higher relevance, basically. It's a stronger connection to its top category. So that's, you can quickly intuit that and read that, and that's really hard to explain, but that's why we can read it like we read a face, because you associate the, yeah, that's how you get to location being movement, not proximity. Any more questions from the chat?
So I know we drifted away from the presentation.
No,
And have gone through all the questions, which is great, and made the presentation more interesting. So anyone else? Anyone else in the stream, in the chat? Or is there areas that you would like to add?
Oh, buy my book. If you have any kind of high stakes sales situation, I love to talk about the CRM, which will prove that you need to buy the book, and that permissions can't be done this for AIs or agentic in any other way than with this kind of map that I just showed you. So those are the two products, if you will. The main idea here is that we're going to license kind of a facade, a wrapper pattern of that map for different systems in different ways. So it's probably going to be completely open source, but because it's grounded in physics, right? A processor that is dealing with a map that drifted from reality is going to have to work harder because it's not a sorted list anymore, based on the problem space that I was in. So it has huge financial upside here, but to make such a massive change happen, it has to have a clear upside. So I'm looking for everything, basically. I'm looking for people who know people who might be interested in helping this. Decentralization and verifiability are absolutely key to why do this. And if anyone knows why this, because I've been making noise for a long time, and maybe I haven't been understood before, that is possible. But it seems that either I'm insane or I'm onto something. And I'm not sure which it is, because maybe I just haven't been clear enough. That's possible. So I have questions about how clear I was, basically. Can you see the new color?
Does anyone want to share feedback? And that also goes for student audience.
Even if we didn't kind of see color, what would you like for us to like walk away with this from this talk? Is there something that you can miss on that will get us to want to see the color, want to read the book, want to get more interested?
Do you want to make the case for AGI? And maybe
I'll start with the one question, and then I'll try to use it to make the case. So the takeaway in a real way is that I'm making the case that if you believe that a sorted list is easier to deal with than a random one, then what you're holding in your hand is basically a sorted list of a totally different kind. So it should make sense that drift should be visible in this way. And if it is, we have hope that a lot of the impossible questions that we deal with are actually possible. And that means that we can close the gap between what we meant and what was heard or understood, or what happened, basically, which seems important if you're driving fast. That's the big one. So it's a kind of hope, basically. When you constrain the meanings of symbols, then you can have grounding, and that means you can have agency and freedom. So you become unfree when meanings drift all over the place. That's why your brain hurts in a meeting with 5 people from 5 different careers, to bring it back to that. I think most people had a similar type of experience. And I don't want to see AGIs without an equivalent function capability to what we do when we do Hebbian learning. So neurons that fire together. If they're not based in reality like we are, I see problems with that. That doesn't seem to have a lot of good endings. So that's the takeaway. The takeaway is that, yeah, this needs to happen, basically. We need a steering wheel. Yes. Oh. Now, the grounding is in the representation of the problem space that you made. It's not, and if that fits reality, it will act as a sorted list. You'll get fewer cache misses. If it's out of sync with reality or what you're trying to achieve, you'll get more cache misses. So how to get that together isn't as hard as it sounds. That can be done in lots of different ways. But it's never, like, this system doesn't ground you in reality the same way that we are, but hopefully it does in an equivalent way, an equivalent enough way, basically. So frame of reference is what causes the cache misses. It's the same kind of thing. If your frame of reference drifts from your description of the problem, that will force you to think more, just like being in a meeting with 5 different careers in it. We have 5 different dictionaries, 5 different ways of talking, right? If every word, even, what does sales look like, or what does revenue mean? If that means 5 different things, you're going to get a headache real quick. And those are frames of reference. And that is, the hope is that if those are detectable, if they create physical phenomenon, cache misses, basically, that is what we would need to not be on an icy road trying to steer a car, right? That works if you go slow. If you go fast, you'll end up in the wrong place. So that's version of that. I hope I answered that question.
Misha has a follow-up question.
It was a little bit late to ask this, but what's the difference between a circle and a pyramid? Other than the fact that one's a circle and one's a pyramid. Versus flat versus whole.
So that's the same question, asked in a better way. In this case, the pyramid is the happy, or red in this case. The mind blown is the blue here, and the devilry one is the smooth one. So in this version on the book site, that's what it is. It basically means that the top categories, those three top categories, get their own colors or shapes, which makes it so you can read the whole thing as a map. And when you extrapolate that with this one is a position 1, so happy is in position 1, ideas is in position 2, and trouble is in position 3. So they're in the same area. That means that you can read it by location. So they're, in this case, they stand for those ideas. They stand for those symbols. So we can ground in those symbols. They have explicit, exact connections to each other and their subcategories. So they could mean anything. You can fill in any, you can make, go on.
Is directionality important?
Yeah.
So, okay, yeah. It's like, left bank, there's left bank decode the right bank different from, if you switch the indices around. So it can be different.
The axes are symmetrical. They're always symmetrical with that.
IJ versus JI.
The weights are not symmetrical. So the axes are symmetrical, the weights are not, basically. So this team decided that happy came first, then mind blown, and then devilry. That leads to the other stuff. So that's an implied prioritization, the weights. So that's a value judgment that the people who, like the LLM that made this, figured out.
Okay, as we are closing the session, I also would like to mention that our speaker is from London, and I'm especially saying that for the stream. Any other questions before we close it? Say it again.
Any questions?
Any questions in the stream?
Do we have any questions from the stream? Yeah. I can try to get the volume working so you can speak, or otherwise only I will hear you right now. Did you type the question or did you write the question, Benito? You're muted. If you unmute, at least I will hear you.
Benito, do you mind typing the question?
You can type the question or you can unmute. Either way works.
No question from me. I just want to make sure we didn't see the screen. So
yeah, I'm sorry that we had a bunch of technical issues today. A bunch of them. So anyone who tried to download the book early in the week would have been able to do so. If you put it off until today, you would not have been able to.
I have included the